In this video, I'm going to give you some terminology. So we've seen this harmonic series in the past. We've seen many times that this harmonic series will diverge. And then when you look at the alternating harmonic series, remember this block is causing it to go minus, plus, minus, plus, and so on. We've also seen that this thing here will, well, it's quite strange in that 1 over n here will diverge. But then if you have the alternating harmonic series, for some strange reason, it will converge. So this thing here will diverge, but when you have an alternating harmonic series, it will converge. And we've seen this in the past. So try and understand why it converges. So if you look at this here, so this is your alternating harmonic series. You've got minus, plus, minus, plus, and so on. It's alternating, and it's getting smaller each time. This is a half. This is a third. It's getting smaller and smaller each time. So when you start at 1, and then you take away a half, so you go back a half, that will then take you here, and then you add a third, which is less than a half. So you won't go all the way back to 1. You would go to somewhere around here, and then you take away a quarter, so which is less than a third. So you would go back to here, and then so on, and then you go back here, and then you go back. It's getting smaller and smaller, and eventually you will converge to some sort of limit. You will converge. So we've seen that in the past, and also we can use the alternating series test on this. We've also seen this in the past. This has been satisfied. This has been satisfied. This has been satisfied. All three have been satisfied. Therefore, we can conclude that this thing will converge. We've seen all this in the past. So, hang on. So, when given this alternating harmonic series, if you apply the absolute convergence test on this, remember the absolute convergence test is you're trying to investigate a series, but then the absolute convergence test is saying you should have a look at the absolute version of this. Well, the absolute version of this will then give us this. If you're trying to investigate this, the absolute convergence theorem says, sorry, the absolute convergence test says that you should look at the absolute version of this. Remember, sine n oscillates between 1 and minus 1. 1 minus 1, 1 minus 1, and so on. But if you look at the absolute version, this is trapped in between minus 1 and 1. Well, we've done this in the past. The absolute version of this will then take you to here. Now, hang on, let's start again. We're trying to investigate this using the absolute convergence test. That will then take us to here. We are trying to investigate this. Look at the absolute convergence test. That will then take us to here. But this thing here will diverge. But then we know that this will converge. And then if you look at this here, this will converge, and then this is also this will also converge. So hang on, this thing here will converge. But then if you apply the absolute convergence test, it will diverge. So we say that this series is conditionally convergent. And then if you look at this here, this thing here converge, and this also converge. This series is absolutely convergent. We say it's absolutely convergent. This thing here, well, if you apply the apps here, this thing here will diverge, but the actual series itself will converge. So this series is conditionally convergent. This thing here is absolutely, because when you look at the absolute, it will converge. This will also converge. So this series here is conditionally convergent. This is absolutely convergent. Just terminology, nothing more. It's just terminology. Okay.